On November 19th, 2025, somewhere off the coast of Scotland, a British maritime patrol crew was flying one of the most advanced surveillance aircraft in the world, a machine worth around $200 million. Everything seemed controlled. The crew was watching the sea, tracking movement, checking signals, and monitoring one specific vessel that had no business acting suspiciously in such a sensitive area. Then, without warning, the cockpit was flooded with a sharp green glare. For a few seconds, the pilot's vision was overwhelmed. The crew had to react instantly. In the darkness over the North Sea, even a small mistake could become a serious emergency. Below them, on the deck of the Russian vessel Yantar, someone may have believed they had just forced the British aircraft away. But that was the mistake, because the moment that beam appeared, it did not scare NATO off. It did the exact opposite. It exposed the ship, confirmed its intentions, and activated a coordinated response that had been quietly waiting in the background. The Russian crew may have thought they were turning off the lights around themselves. Instead, they had just switched on a signal flare. To understand why this mattered so much, look at where Yantar was operating. The ship was positioned roughly 45 miles off the coast of Scotland, inside the United Kingdom's exclusive economic zone. This is not just open water. This is one of the most important underwater crossroads in the Western world. On the seabed below that area lie major undersea communication cables, including systems like Cantat-3 and Atlantic Crossing 1. These cables are not just pieces of infrastructure, they are the hidden nervous system of modern life. Bank transfers, business emails, cloud services, global markets, streaming platforms, and even videos like the one you are watching right now depend on networks like these. Most people imagine the internet as something floating in the air, moving through satellites and invisible signals. But the truth is far more physical. A huge part of global digital traffic runs through thin fiber optic cables resting silently on the ocean floor. If those cables are disrupted, the consequences are not limited to slow websites. Financial systems can stumble. Companies can lose access to data. Communication between continents can be interrupted. Entire markets can feel the shock. That is why this area is so sensitive. It is not a fishing zone. It is not a casual shipping lane. It is a pressure point in the global economy, and the vessel moving slowly above it was not an ordinary research ship. Officially, Moscow describes Yantar as an oceanographic survey vessel. That sounds calm, scientific, almost harmless. It sounds like a ship designed to study currents, map seabeds, and collect marine data. But NATO views vessels like Yantar very differently. In Western naval circles, ships of this type are often seen as intelligence platforms with a very specific purpose: to observe, map, and potentially interfere with underwater infrastructure during a major crisis. Yantar is connected to Russia's Deep Sea Research Directorate, a highly specialized organization focused on underwater operations. The ship is equipped with advanced sonar, seabed mapping equipment, and most importantly, deep diving submersibles. Among them are vehicles such as AS-37 Rus and AS-39 Consul. These systems can descend thousands of meters below the surface, far deeper than ordinary divers or standard underwater equipment could ever reach. Their robotic arms are not there for tourist photography. Their purpose is to interact with objects on the seabed, inspect them, and, if ordered in a crisis, potentially interfere with critical infrastructure. Legally, Yantar could claim it had the right to be in international waters or near the edge of sensitive zones. But legality and intention are two different things. And that night, the United Kingdom was not guessing. They were watching a vessel with a long history of concerning activity. Yantar had previously been observed near major underwater infrastructure in the North Atlantic. It had appeared in areas connected to pipelines, communication routes, and seabed networks. Throughout recent years, it had repeatedly drawn attention for operating close to submarine cables that connect the United Kingdom and Europe to the wider world. This was not a random appearance, it was part of a pattern, and that pattern pointed to one conclusion: Russia was likely trying to identify, map, and understand the weakest points of the underwater systems that keep the West connected. The idea is simple. In peacetime, you study the map. In a crisis, you already know where the pressure points are. That is why Yantar's behavior immediately raised concern. Since early November, the ship had reportedly turned off its automatic identification system known as AIS. For civilian vessels, AIS is like a public license plate. It broadcasts a ship's name, location, direction, and speed so that other ships can avoid collisions. Commercial ships are expected to keep AIS active. When a vessel switches it off, especially near sensitive infrastructure, it sends a very clear message. It is trying not to be seen. But switching off AIS only works against ordinary traffic. It may confuse merchant ships, it may reduce visibility on civilian tracking websites, but it does not make a ship invisible to military surveillance, and certainly not to a Royal Air Force P-8A Poseidon. The P-8A is built for maritime patrol. It can detect ships, submarines, surface movement, heat signatures, radar emissions, and acoustic activity. It does not need the target to politely identify itself. That night, the British crew saw exactly what they needed to see. The ship was dark on AIS, but it was still present on radar. It was moving slowly, tracing a deliberate zigzag pattern across the water at around 3 to 5 knots. In naval terms, that kind of movement is rarely innocent. A vessel moving slowly in repeated lines above the seabed is often conducting a scan. It may be mapping the bottom, searching for underwater structures, or aligning itself with something below the surface. Imagine seeing a truck moving slowly through a quiet neighborhood at 2 a.m., lights off, license plate covered, circling the same block again and again. You do not need a full investigation to understand something is wrong. The British P-8A descended and began collecting confirmation. Its radar and infrared systems scanned the sea surface. Its electronic support measures listened for signals. Its sensors searched for patterns that did not belong. Then came the most important detail. There were signs of unusual movement in the water, along with thermal activity suggesting that something had briefly surfaced or moved close to the surface near Yantar. It may have been visible only for a short moment, but in modern surveillance, a few seconds can be enough. The British crew had likely caught evidence of underwater activity. And when the Russian crew realized they had been observed, they reacted. Instead of calmly continuing on course, Yantar activated a defensive optical system and directed a powerful green glare toward the British aircraft. This was not a harmless flashlight. A directed laser or optical dazzler aimed at an aircraft can affect cameras, sensors, and even the crew's vision. In a low-altitude maritime patrol environment, that is a serious escalation. The goal was obvious: disrupt the aircraft, force it to move away, and create a short window of time for the underwater system to reposition or disappear. But that decision changed everything. Because the moment Yantar used that system, it gave NATO exactly what it needed: confirmation, signal data, and justification to move from observation to coordinated containment. The British pilot followed procedure. He did not take unnecessary risks. He pulled the aircraft away from the most dangerous angle and climbed to a safer position. On the deck of Yantar, someone may have thought the aircraft had been pushed back, but the British crew had not lost the target. Before repositioning, they had already marked the area, logged the ship's behavior, and shared the coordinates through Link 16, the secure data network used by NATO forces. Think of Link 16 as a military group chat, but instead of text messages and photos, it sends live coordinates, identification data, threat updates, and sensor information to allied platforms in real time. The human eye might be disrupted for a moment. The network was not. The British aircraft had effectively pinned the location on the map and told every friendly unit nearby. This is the spot, this is the activity, and this is the vessel. And the United States Navy was already in the area. That should not be surprising. Since the escalation of tensions in Europe, the North Atlantic and the waters around the United Kingdom have become a permanent focus of NATO attention. The GI-UK gap, the stretch of ocean between Greenland, Iceland, and the United Kingdom, is especially important. For Russia's Northern Fleet, it is one of the key routes into the Atlantic. For NATO, it is a gate that must be watched constantly. This is why the United States and the United Kingdom maintain a persistent presence in the region. The idea is simple. You do not wait for a crisis and then start looking. You stay close enough that when something happens, you are already there. Somewhere below the surface, a U.S. Navy submarine was reportedly positioned in the wider area, listening. While the aircraft watched from above, the submarine listened from below. That is where modern naval operations become so difficult to escape. A surface ship may hide its AIS. It may operate in darkness. It may try to mask its intentions. But every machine has a signature. Engines create vibration, pumps create rhythm, propellers create patterns, even small submersibles make sounds that trained sonar teams can identify. To an experienced sonar operator, the ocean is not silent. It is full of fingerprints, and if a Russian deep-diving vehicle entered the water, its movement would not be ignored. The American submarine moved into a position where it could listen without revealing itself. It collected acoustic data, tracked movement, and built a picture of what was happening beneath Yantar. At the same time, the Russian ship had created another problem for itself. To aim its optical system accurately at the British aircraft, Yantar had to activate navigation sensors and targeting support systems. That meant sending energy into the electromagnetic spectrum, and when a military sensor system transmits, it leaves a trace. Above the area, another U.S. Navy P-8A was reportedly operating in a quiet monitoring role. It was not there to make noise. It was there to listen. Its electronic intelligence systems captured the emissions coming from Yantar: frequency, pulse pattern, bandwidth, timing, and behavior. In simple terms, the Russian ship had just handed NATO a digital fingerprint of its equipment. The coordinates from the British aircraft gave NATO the address. The electronic data gave NATO the key. What Yantar may have intended as a few minutes of confusion became a major intelligence loss. Instead of creating cover, it exposed itself across multiple domains: visual, radar, infrared, acoustic, and electronic. Now the situation shifted. The underwater vehicle was believed to be in the water. Yantar was waiting. The crew likely assumed the British aircraft had been pushed away and that they had gained a narrow window to continue, but the sky was not clear, the sea was not empty, and the network was already awake. The USP-8A reportedly sent a narrow radar signal into the area, not as an active strike, but as a message. It was a controlled pulse, just enough to touch the Russian ship's awareness and then disappear. In military terms, this is a warning tap on the shoulder. It says, "We see you." No shouting, no dramatic announcement, just a precise signal in the dark. The captain of Yantar would have understood the meaning immediately. His ship had been detected, marked, and boxed in by forces he could not fully see. So the Russian crew tried a classic move: create confusion. Yantar reduced its emissions, attempting to disappear electronically. Below the surface, the underwater system likely released or relied on an acoustic decoy, a device meant to imitate movement and draw attention in the wrong direction. The idea is familiar. Throw noise one way, move the real asset the other way. But this only works if the other side reacts too quickly. The American submarine did not chase the distraction. Its sonar team kept tracking the real pattern. A decoy may imitate a general sound, but it rarely copies all the tiny details of a real craft moving under pressure, adjusting depth, changing speed, and responding to commands. A trained crew can tell the difference. Instead of rushing toward the false trail, the U.S. submarine maneuvered quietly, positioning itself behind the Russian vessel's area of movement. It stayed in the blind spot, where detection would be far more difficult. This is where the balance changed completely. From the Russian perspective, they may have believed they were still conducting a controlled operation. From NATO's perspective, the Russian ship and its underwater system had already been surrounded by sensors. Then came the pressure. First, communication became unreliable. A deep-diving vehicle depends on its mothership for navigation updates, coordination, and recovery guidance. If the link between the two becomes unstable, the entire mission becomes far more difficult. The US aircraft and allied systems reportedly began electronic pressure against the communication channel being used by the Russian side. Not a dramatic movie-style shutdown, but something more precise: noise, interference, and disruption in the exact space where the Russian system needed clarity. Imagine trying to whisper instructions across a dark room while someone keeps turning on static at the exact frequency of your voice. That is what this kind of electronic pressure is designed to do. On Yantar's screens, clean telemetry may have become unstable. Position data may have become unreliable. The underwater vehicle would have been much harder to guide safely and accurately. The mission was no longer controlled, it was becoming a liability. Then came the second message. From beneath the surface, the American submarine reportedly sent a single active sonar pulse. One ping, sharp, metallic, unmistakable. For a naval crew, that sound is not just noise. It is a statement. It means an advanced submarine is close enough to identify you, close enough to track you, and confident enough to briefly reveal its presence. The crew on Yantar would have understood immediately. The threat was not somewhere over the horizon. It was nearby, possibly right under their own operating area. At the same time, the British P-8A returned to the scene. Its sensors were active. Its search system swept the Russian vessel from above. The earlier attempt to push the aircraft away had failed. Now the message was coming from every direction. From the air, you are being watched. From the sea, you are being tracked. From the electronic spectrum, your systems are known. From below, your underwater asset is not hidden. There was no need for a direct confrontation. The situation had already been decided. The Russian captain had one practical choice: recover the underwater system and leave. And that is exactly what happened. Yantar began emergency recovery procedures. The underwater vehicle was brought back aboard. The ship turned north and moved away from the sensitive area. The same vessel that had tried to operate quietly near critical undersea infrastructure was now being watched openly by Allied aircraft. The lasers were off. The mission was over. The Russian ship was no longer setting the tempo. It was being escorted out of the area by a network it had failed to escape. Not a single shot was fired, but the outcome was still clear. This was not a victory of size, noise, or intimidation. It was a victory of integration. Russia used an old-style pressure tactic: shine a powerful beam, disrupt the aircraft, create confusion, and hope the other side backs away. But NATO answered with something far more effective: shared data, layered sensors, electronic intelligence, underwater tracking, and disciplined coordination. Modern maritime security is no longer about who can shout louder. It is about who can see the full picture first. You can interfere with a camera. You can force an aircraft to change altitude. You can turn off your AIS and pretend you are not there. But you cannot easily disappear from radar, infrared, sonar, electronic monitoring, satellite awareness, and allied data networks all at the same time. That is the lesson of this encounter. The ocean may look empty from the surface, but in a high-tension region, it is full of invisible lines. Signals, sensors, acoustic tracks, digital reports, and command networks are all connected. Yantar may have believed it was operating in darkness. In reality, it had sailed into a digital cage, and once that cage closed, every move it made only added more information to NATO's picture. The deeper lesson is even bigger. Critical infrastructure is now part of national security. Undersea cables are not just technology. They are economic arteries. They carry money, messages, decisions, contracts, orders, videos, calls, and the daily rhythm of modern civilization. That is why the West cannot afford to treat suspicious activity around these cables as routine. A ship like Yantar does not need to fire anything to create concern. Its presence alone in the wrong place, moving in the wrong pattern, with its identification turned off near vital cables, is enough to trigger a major response. And that response showed something important. The United States and the United Kingdom are not simply waiting for something to happen. They are watching the routes, monitoring the patterns, and building the kind of shared awareness that makes hidden operations much harder to complete. For Moscow, the message was uncomfortable but clear. You may send a survey ship. You may turn off your public signal. You may launch a submersible. You may try to distract the aircraft above you. But the moment you touch the network touches back. This was not just an interception. It was a demonstration. A British aircraft identified the suspicious activity. A NATO data link spread the information instantly. American sensors captured the electronic fingerprint. A U.S. submarine tracked the underwater movement. Electronic pressure disrupted coordination. A sonar signal delivered the final warning, and the Russian vessel left without completing its objective. That is 21st century maritime control. No dramatic explosion, no open clash, no unnecessary escalation, just quiet dominance through information. And that may be the part that worries Russia most, because a ship can be replaced, a route can be changed, a mission can be delayed. But once your systems are identified, recorded, and studied, the next attempt becomes harder. Every signal you used becomes a clue. Every reaction becomes a pattern. Every mistake becomes training data for the other side. Yantar left the area, but it likely left behind something far more valuable than it intended. Information about how it behaves under pressure. And NATO will remember that. So the question now is simple. After being exposed, tracked, disrupted, and forced to withdraw, will Russia risk sending Yantar or another similar vessel back into these waters? And if next time Moscow sends something more capable than a so-called research ship, how should the United States and its allies respond? Should they continue with quiet warnings and precision containment? Or has the time come for an even firmer response when critical undersea infrastructure is put at risk? Share your thoughts in the comments below. And if you want more sharp military breakdowns like this, make sure to like the video and subscribe to the channel. Thanks for watching, and I'll see you in the next one.